Dear students, today we shall study the inverse Laplace transform of integrals. Last video it was given inverse Laplace transform of derivatives. Now we consider integrals. So this is our headline, inverse Laplace transform of integrals. Now we know this formula LFT equal to f of s. So if ft dividing by t, then we get integration s to infinity fs ds. We know this formula. So if we taking L in right hand side ft by t, then this will be L inverse integration s to infinity f of s ds. Now if we multiplying this t right hand side, ft equal to t L inverse integration s to infinity fs ds. We get this. Now ft means this is ft, L of ft equal to fs, ft equal to L inverse fs. So this can be written as L inverse fs, this equal to t L inverse integration s to infinity f of s ds. So dear students, this is a formula. This is a formula of inverse Laplace transform of integrals. So L inverse fs we can write t L inverse integration s to infinity fs ds. So this is our formula, L inverse fs equal to this formula. Now we want to solve one problem by using this formula. Now let us consider one example. So this is our formula. Now we want to solve this problem. Obtain L inverse twice s by s square plus 1 whole square. Now we want to solve this problem. L inverse twice s by s square plus 1 whole square. So this formula L inverse fs equal to t into L inverse integration s to infinity fs ds. Now we multiplying t, first t L inverse within bracket s to infinity integration s to infinity fs ds. Fs means this twice s square plus 1 whole square ds. We get this one. Now we want to write here this one t, this L inverse remains same. Again you know this formula integration f dash x by fx to the power m dx. This equal to minus 1 by fx minus 1 by m minus 1 fx to the power m minus 1 plus c. We know this formula. So we know this formula f dash x by fx to the power m dx. Then answer is minus 1 by m minus 1 fx to the power m minus 1 plus c. Now if we differentiate fx, we get f dash x. If differentiation of denominator this given in numerator, then answer minus 1 by m minus 1 fx to the power m minus 1. So if we differentiate s square plus 1, then we get twice s. So this differentiation given here, this is fx, this is f dash x, then this will be minus 1 by 2 minus 1 s square plus 1 s square plus 1 2 minus 1 s to infinity. We get this one. So dear students, line is clear. Just differentiation of this given in numerator. If differentiation fx equal f dash x, differentiation of this given in numerator minus 1 by m minus 1 fx to the power m minus 1. Or we can write fx equal to u, this equal to u or z also we can solve. Same method. T L inverse minus 1 by s square plus 1 we get s to infinity. So minus taking outside, L inverse 1 by s square plus 1 s to infinity. So minus t remains same, L inverse remains same, putting the upper limit 1 by infinity square plus 1 by, this is s equal to s square plus 1. We get this one. This line is clear. Just putting infinity here and next putting s equal to s. So 1 by minus t L inverse, this is infinity square is infinity, infinity plus 1 is infinity, and minus 1 by s square plus 1, we get this minus t L inverse, something by infinity we know 0, 1 by s square plus 1, we get this one. Then this 0 cancel, minus and minus plus, we get t L inverse 1 by s square plus 1. So this is direct formula, we get t 1 by s square plus 1 square. This will be sine 1t, or we can write sine t. So this is t sine t, and this is our nice answer. This one our answer. So this formula is, we know this formula, L inverse a by s square plus a square, this equal to sine 80. We know this formula. So using this formula, a means 1, you can write this 1 square, a by s square plus a square, a by s square plus a square, so sine 80, a means 1t, or t sine t, this is our answer. Now let us consider this example. Find the inverse Laplace transform of 1 by s square minus 5s plus 6. Now we want to solve this problem. L inverse 1 by s square minus 5s plus 6. We want to solve this problem. First we factorize this s square minus 5s plus 6. This equal to s square minus twice s minus thrice s plus 6. Middle term break, s common, s minus 2, 3 common, s minus 2, and s minus 2 common, s minus 3 we get. So if we factorize, we get this. Now we write in factor form 1 by s minus 2, s minus 3 we get. This line is clear. Just putting this result, this equal to this, we putting this result here. Now this is actually partial fraction. If we taking partial fraction, then this will be log. So dear students, in case of partial fraction, if numerator is constant, then we can solve easily. But if numerator is variable, then we shall use the partial fraction. But here numerator constant given, we can easily solve this problem. Now what is the technique? The technique is that we write this in difference of two numbers, s minus 3 minus 1 by s minus 2. We write difference of two numbers. Now again, if we taking LCM of these two, LCM, then s minus 3, s minus 2 is LCM, here s minus 2 minus s plus 3. S cancel, 3 minus 2 is 1. So we get 1 by s minus 3, s minus 2. We get this one. S minus 3, s minus 2. Ultimately, if we calculate this, we get this one. Now we are taking L inverse with this, L inverse with this. So L inverse 1 by s minus 3 and L inverse 1 by s minus 2. So up to this clear? This is nothing. Just we taking L inverse with this, L inverse with this. Now we know the formula. L inverse 1 by s minus a, this equal to e to the power at. This is our formula. Now using this formula, here a means 3, L inverse 1 by s minus a, e to the power 3t, and 1 by s minus a means 2, e to the power twice t. So this line is clear. So if this line is clear, then this is our final answer. So dear student, this solution is easy. No one can say this solution is difficult. So if we taking partial fraction, then also we get same result, but if numerator, you have to remember, if numerator is constant, then we write in difference of two numbers. So this will be shortcut method. So otherwise we can solve in partial fraction also. So today stop here. Thanks.